Welcome to Aletheia-TV-Network. I'm your host for the Holistic and Natural Health University. In this program, I will talk about what cancerous tumors eat and how to poison them. This topic has been investigated by the cancer researcher Dr. Crystal Souls. And when Crystal started researching how tumors grow and develop was when her aunt was diagnosed with breast cancer. She wanted to do everything possible and learn about all the available treatment strategies. The breast cancer that her aunt had was HER2 positive. This represents one of the earliest and most famous examples of cancer subtype that has a precision medicine associated with it. In this case, Herceptin. For Crystal, the difference between precision medicine and traditional chemotherapies is a little bit like the spraying of a field with a crop duster to get rid of weeds, instead of going in and spraying just each individual weed to get rid of it. The challenge in cancer is that we can't always tell the difference between the weed and the crop, or maybe we can tell the difference, but we don't have an effective pesticide yet. Or maybe, like in the case of Christy's aunt, we can tell the difference between the weed and the crop. We think we have an amazing pesticide while starting treatments, but ultimately the patient stops responding and relapses. In Christie's lab at San Diego State University, they are trying to know and how these weeds work in tumor drivers. These tumor drivers can happen as a result of any random genetic mishap, a mutation, deletion, amplification. For example, you are a protein and your job is basically to be stationed right outside the cell, and you are constantly scanning and looking for clues about the health of the environment, whether there's a lot of resources around. And if you determine that times are good, you change your shape in just such a way that your signal to inside the cell is great. And that cell now knows that it can grow and divide and grow and divide. But imagine that you pick up a mutation and so now you're stuck in that growth shape. So times could be bad, very dark indeed, but you're still sending that message of grow and divide constantly. Or imagine you can still make the right shape at the right time, but maybe instead of 10 of you surrounded around the cell, maybe now there are 10,000 of you lining that cell. And so now you're screaming that message instead of just saying it. That's a little bit like what happens in the case of HER2 plus breast cancers. So we're starting to think about tumors less in terms of their tissue of origin, breast cancer, lung cancer, prostate cancer, and more in terms of their drivers. EGFR positive, HER2 positive, P53 mutated. Because these drivers, it is true that they can represent essentially a superpower for the tumor. But it's important to know that these tumor drivers can also represent an Achilles heel, because these tumor cells become so reliant on these pathways, so addictive to these pathways, that if you can go in a strategically shut down just that pathway, well, you're going to harm the tumor cell way more than you're going to hurt any other cell in the patient. And of course, that's always what we are shooting for in precision medicines in cancer. One of the most interesting examples of Achilles' heels is tumor metabolism, or how tumors eat. So let's say, for example, you look inside the cell and you see a protein that's catalyzing hundreds and hundreds of reactions in a second, which is extraordinary. They can do this. And it's not just that one protein, but there are thousands and thousands and thousands of proteins that are catalyzing a variety of different chemical reactions at any time. Cells often have a decision that they must make. Are they going to use that tasty food that you just ate, whether it's chocolate cake or burritos or salad? Are you going to devote basically all that tasty food towards driving these chemical reactions? Or do you need to save some of that food towards making stuff, making the protein and the DNA and all the cellular components that you need for a cell to grow and divide? Well, even though it sometimes feels like this is not true when we stand on the bathroom scale in the morning, most of the cells in our body are actively growing and dividing all the time. And so this is really an important factor in tumor cells, that they are having to balance these two needs to grow and divide and power reactions. And so we have known for a long time that tumors eat differently than non-proliferating cells. They do this in a couple of ways. They might simply take on a lot of more glucose, which is cells' usually favorite dish. Or they might be a bit more open-minded about what food it is. Instead of just glucose, maybe these cells are using glutamine or serine or some of these other small molecule building blocks to allow these cells to rapidly grow and divide. In Crystal's lab at San Diego State University, they are interested in understanding how these changes in tumor metabolism occur. And one of the proteins that they are really interested in called isocitrate dehydrogenase, or IDH. And this is a very important protein that basically helps balance levels of important metabolites or small molecules that are needed in the cell to power a lot of these different metabolic reactions. And so, unfortunately, you can develop a mutation in IDH that, well, for one, breaks the protein. It can't do the reaction that it's supposed to do, but it gets worse. What also happens is that these mutations allow this enzyme to perform and brand new chemical reactions that it was never before able to do, a superpower. And this superpower is making this metabolite that is kind of like a carcinogen if it builds up too high levels in the cell. It basically creates a pro-tumor environment, and it helps the cancer to be formed. So, in her lab, they are interested in understanding how to shut down this particular reaction, because this can be an important therapeutic. So, it may seem like going after cancer metabolism is too dangerous in the context of precision medicine. To be fair, most cells in the body need to grow and divide at some time. And it's true, sometimes we can get the selectivity that we need to shut down strategically just cancer metabolism. But in the case of IDH, that single mutation, that one change out of 3 times 10 to the 9 size genome that we all have, that single change modifies the shape of the protein just enough where it can perform the new reaction. It gets a superpower. But it also changed the shape just enough where you can design a small molecule therapy, a drug that can strategically go in and just shut down the mutant. That's extraordinary. So what do we know so far? Well, in her lab at San Diego State, they have found a particular type of IDH mutant that's kind of a troublemaker gone wrong. What happens is that this particular mutant makes buckets and buckets and buckets of this dangerous metabolite. And not only that, it doesn't seem to bind these therapies particularly well. This still means we have a lot more that we need to learn and IDH and tumor metabolism in order to help every patient that has cancer, that has this type of problem in the genome. A graduate student in Crystal's lab that was helping perform some of these experiments was doing so while his own father was dying of colorectal cancer. It is absolutely true that honest scientists in general are motivated by their love of discovery on how humans and other organisms work based on by their own stories and the personal narratives of those in our lives that we love. It's critical to find new ways to combat cancer. Thank you very much for watching. I hope you can share this information with your loved ones and the people that you have connections with. Have a wonderful day.